We have two matrices A and B, and the question asks us to find A plus B, which is the sum of A and B. Before you can think about adding a matrix, you want to make sure that they have the same rank. And when I say rank, I mean the order, dimension, or the size, which means the number of rows by the number of columns. So the rank for matrix A, number of rows by number of columns. Number of rows, 1 row, 2 row. By number of columns, 1 column, 2 column. So the order of the rank for matrix A is a 2 by 2. We need to check the same for matrix B. Number of rows by number of columns. Number of rows, 1, 2. By number of columns, 1, 2. So B, the matrix, is also a 2 by 2. This is important. Before you can add a matrix, the rank of both matrices, or even 3 matrices, the number of matrices must be the same. So if you're going to add A and B, the rank for A must be the same rank as B. If you're going to add B to C, the rank of B must be the same rank as C. Get the gist? So seeing that these two ranks are the same, then we can go ahead and add them. So how we go about adding them now is special. You have to add each element to the next element of the next matrix that are in the same position. So row 1, let me just show you. In row 1, column 1 of A, we have the element 1. And remember, we're adding. It must be in the same position as the element in this one. So row 1, column 1 in matrix B is -5. So I'm adding a -5 here. And this will result to be, the answer for this will be in row 1, column 1 position in the final matrix A plus B. So I'm finished with this, and I'm finished with that. So I'm going to move on to this one. So this is row 1, column 2 in A, that's a -3. And I'm adding, based on this, to be row 1, column 2, which is -4. And I can close off my matrix because I know that the answer should be a 2 by 2 matrix based on this. So row 2, column 1 in A is 2, and I'm adding that to the element in row 2, column 1 in matrix B. Row 2, column 1, that's 0. Then my last entry, or my last element, would be the element in the row 2, column 2 position of both matrix A and B. So row 2, column 2, -1. And I'm adding row 2, column 2, 2. And all I have to do now is to just work it out. So you have 1. So I'm going to just deal with the sign them first because the signs can be confusing. So a positive with a negative should give me a negative. So this really means 1 minus 5, which is equal to -4. So in my final answer, -4 is going to be here. Just neat it up. A plus B is equal to this. So may I deal with the sign first because we can't get out of confusion. Positive with negative should give you a negative. So this is really -3, take away 4. So I'm owe 3 and I owe 4 more. So I end up owing 7 in all. So my entry for this is going to be -7. 2 plus 0 is 2. You owe 1 and you pay up 2, so you still have 1. So the matrix A plus B is this one right here, and that's it. So let's try the subtraction now. So here it says we need to find A subtract B, or the difference between A and B. Remember, when you're doing addition or even subtraction, you want to make sure that the rank for both matrices or even three matrices are the same. So as we said before, number of rows by number of columns. 2 rows by 2 columns again. And it's the same thing for B. 2 by 2. When you look, the ranks are the same, so I can go ahead and subtract. If the ranks were different, it couldn't work out. I just write a statement say cannot be worked out as the ranks are different. So now, because the ranks are the same, that means I can go ahead and subtract them. So I'm going to go ahead and set up my working matrices and look for the elements that are in the same position. So 1 is in the same position in matrix A as the -5 in matrix B. So in my working matrix, I'm going to have 1. And remember, so we're taking away this time. Take away. And I'm going to use my brackets to guide me, -5. So that would be the first entry. I'm going to do this one next. So it's going to be -3. And remember, I'm subtracting. I'm going to be using that bracket. And this -3 corresponds to this -4. Alright? Finish with all of that up there. So look here now. So you're going to have 2. I'm subtracting. 0 is in the same position. See? Row 2, column 1, row 2, column 1. And then now the last entry. Row 2, column 2, that's -1. And I'm subtracting row 2, column 2, that's a +2. There we go. That's my working matrix. Now I need to sort out these signs so that I don't get confused. So a negative is reversing this negative. So a negative with a negative here give us a positive. So this is really saying 1 plus 5, which is 6. So now that 6 going to come in my final matrix at the top right there. And I have this negative and this negative here. The negative reverses a negative, so I get a positive. So this is a +4, -3. So if I owe the people them $3 and I pay them 4, that means I should get back 1. And then we know this one going to be 2. And this one going to be negative as well. This one going to be a -3. Because you owe them 1 and you go back and owe them 2. So it becomes a -3. So the final matrix would be 6 in this position, 1 in this position, 2 here, and -3 here. And that's it. So you need to be careful about these negative signs because you have to watch this and these things, right? So we're looking at scalar multiplication now, and a scalar really just means that you're making a number either bigger or smaller by a single number. And here we have matrix A, and the question is to find 2A. So the scalar in this case is 2. It's saying that we're making the matrix A twice its size. So if this is A, I need to make matrix A twice its size. So there's a reason why I called scalar multiplication, because we are going to multiply the entire matrix by a single number. So this is my working matrix, and it simply means that I'm going to distribute. So I'm going to go like this. I'm going to distribute that 2, that scalar, inside my matrix. So I'm going to have 2 times -1 for the first entry there. Then I'm going to come and say, okay, 2 by this 2. So I'm going to have 2 by 2 here. And it continues. 2 by a half. So I need to have 2 times a half. And then finally, you have that 2 by this 3. 2 times this 3. There. That's my working matrix. Now I need to simplify all of this to a final outcome. So negative times a positive will give me a negative. And 2 times 1 is 2. Good. 2 times 2 is 4. And then 2 times a half. I can just simply slash this and put a 1. 22, 1, 22, 1. And all of that works out to be 1. And then 2 times 3, that gives us 6. So this is what 2a is. Twice the size of this. And I can check it. 2 times negative 1, negative 2. 2 times 2, 4. 2 times a half, 1. And 2 times 3, 6. So this matrix is indeed 2 times the size of matrix A. And that's it for scalar multiplication. When it comes to scalar multiplication, the real difficulty is when you're trying to multiply a matrix by a fraction. And it's really just testing your knowledge of fractions. And this will become very crucial when you're trying to find the inverse of a matrix. But just like the other example, you're just going to distribute that scalar, in this case is a fraction, a third, inside to all the elements of A. So I'm going to start off like this. This is the scalar of a third that they said we need to find a third of A. And then I'm putting back all the elements that are inside A. And remember, just like with the distributive property, whatever is on the outside of the bracket, you take it and multiply it by whatever is on the inside of the bracket. So I'm going to take this a third, multiply it by negative 1. So it becomes, in my working matrix now, a third times negative 1. I'm going to also take this third, multiply it by positive 2. So a third multiplied by a positive 2. Notice how I'm taking that scalar and multiplying it by everything inside the matrix. So this is a third now by a half. So that means a third multiplied by a half. Interesting. And then now you have a third again to 3. So it's going to be 1/3 times 3. Now, if you don't know a fraction, you're in a problem. But I'm here to help you a little bit. So I'm going to just rewrite these whole numbers as fractions just to help me. So I can just slash these whole numbers and put 1 underneath them. Because anything divided by 1 is that anything. So 2 divided by 1 is always 2. So I can rewrite every whole number by just dividing it by 1. So then now I can work this out. Positive times negative gives me a negative. And that's 1/3 times 1/3. So my first entry would become negative a third. Negative a third. Same procedure. This is a third times 2. I'm going to turn this 2 into a fraction by slashing it, putting a 1. And then now I'm going to multiply, as the multiplication sign says, the numerator by the numerator and the denominator by the denominator. So 1 times 2 is 2 over 3 times 1, 3. So it becomes 2 over 3. See that? Here now, already 2 fractions I'm working with. So 1 times 1 is 1 over 3 times 2, 6. So I have 1/6 here. And then we have a third times 3. I'm turning this 3 into a fraction by putting it over 1. 1 times 3 works out to be 3. And 3 times 1 works out to be 3. And I can reduce this. 3 into 3 goes 1 time. So 1 comes here. So if I wanted to find a third of A, this is how we go about doing it. And this would have been the answer, given A being this matrix. And you can check it out. When I pick this number, 3 divided by 3 is 1. And 2 divided by 3 is 2/3. -1 divided by 3, -1 over 3. And this one is a little bit more difficult. A third of a half, you just multiply the two fractions that we did here and end up with 1/6.